Hello, I'm Bill Serban, Director of the Center for Advancing Teaching and Learning at the University of Wisconsin-La Crosse. This presentation is part one of a two-part series that examines how and why students experience cognitive overload that results in poor learning. It is based on the idea that our ability to process new information is surprisingly limited, which makes new learning potentially difficult and slow-going. In part two, I will explore how teachers can manage and reduce the cognitive load associated with their lectures, assignments, and class activities to help students learn more effectively. We expect students to take in and think about many new concepts, procedures, facts, and ideas in a short period of time. This leads to a common problem. Students become overwhelmed by too much new information. In a lecture, the instructor delves into a new topic, and in a few minutes, students are struggling to keep up. Or, during a class discussion, students keep jumping from topic to topic. They lose the thread of the discussion and have only a jumble of ideas in their heads. Why do students become overwhelmed? Is it because the instructor goes through the material too quickly? Does lack of organization make it difficult to keep track of the ideas? What about the complexity of the topic? When a new idea is complex, we often have to slow down and think carefully and go back over the material. Other times, when we are talking about a familiar topic, a discussion can be very disorganized, but we can still understand it. What's going on? How can we understand this idea of overload, and what can educators do to reduce it so that students learn more effectively? To understand why we become overloaded by new information, we need to look at two key ideas: working memory and cognitive load. Let's start with working memory. Working memory is the part of our memory system that enables us to hold onto a limited amount of new information for a short period of time. Think of working memory as the mental space where we do our conscious thinking. Whenever we take in new information, mull it over, and think about it, that processing, or thinking, takes place in working memory. Unfortunately, working memory has a limited capacity. We can only hold and manipulate a few pieces of information at one time. So, if we are inundated with a lot of new information, there's a good chance we simply can't process it. We are not able to keep it active in working memory, and we lose it. Working memory is a bottleneck in learning and helps explain why we are overloaded so easily. In school, we are confronted with large amounts of new information to learn and remember. We are endowed with the capacity to retain huge amounts of information for long periods of time in long-term memory. However, we need to actively process new information in working memory in order to turn it into long-term knowledge. Unfortunately, we can process only a limited amount of new information at any given time. To get a better idea of how learning breaks down in working memory, we need to introduce the concept of cognitive load. Cognitive load is the amount of mental resources needed to accomplish a task. Any thinking involves various types of mental processing. Familiar topics or simple tasks do not require much cognitive effort. The load is relatively light. But learning new, more complex information entails more mental effort, more cognitive load. We experience cognitive overload when the demands of a task exceed our working memory capacity. We get bogged down, have difficulty processing the information, and learn less. To illustrate, consider an example of mental arithmetic. If asked, you could easily multiply one-digit numbers in your head. The cognitive load would be relatively light. But what if you had to multiply three-digit numbers in your head? It is quite difficult to keep track of the rows and columns in your head. When the cognitive load of the task exceeds our working memory capacity, we start to falter, make errors, get lost in the procedure, and even give up. Even a relatively simple procedure like multiplication can exceed our working memory capacity. Note that the difficulty has nothing to do with our ability to multiply. You can do complex multiplication problems on paper without much difficulty. The paper serves as an extension of working memory. You calculate a product, write it down, and then you don't have to maintain it in working memory. This example illustrates that humans are endowed with a puny working memory. This limitation makes every learning situation potentially difficult. As we will see, there are ways that teachers and students can manage cognitive load to support more effective learning. But to manage load more effectively, we need to better understand the nature of cognitive load and how it works. Researchers have shown that in any learning situation, there are three sources of cognitive load. In the remainder of this presentation, I will describe the source and type of cognitive processing associated with each type. Imagine that this large rectangle represents working memory. A first source of cognitive load is called essential load. It is the effort involved in simply trying to do a task or learn something new. It is basic mental processing we need to attend to and initially think about a task or material. For example, to multiply two fractions, you need to start thinking about what the actual fractions are, what the arithmetic procedures are, the sequence of steps, and so forth, so that you can start to work out the answer. This is a kind of basic processing essential to do multiplication. Second, generative load is effort involved in trying to understand and make sense of the material. It is deeper processing, such as integrating new information with prior knowledge, that is likely to result in better understanding. This idea of deeper processing may be unfamiliar. Think of it as the kind of effort that goes into making sense out of new information and not simply trying to remember it. As teachers, we want students to engage in this type of processing, but it does make learning more complex. For example, if I am learning how to multiply fractions, I could simply follow the rule and carry out the procedure in a rote fashion. Multiply the numerators, multiply the denominators, and then reduce the fraction if possible. In other words, I could learn to multiply fractions without really understanding what I was doing mathematically. But if I was thinking about it mathematically and trying to understand it, I could realize, for example, that multiplying fractions looks different than multiplying whole numbers. When I multiply 2 times 2, I get 4. When I multiply two whole numbers together, the product is a larger number than the two whole numbers. When I multiply two fractions, 1/2 times 1/2, I get 1/4. When I multiply fractions, I get a product that is smaller than the two fractions. This might lead me to think about how multiplying 1/2 by 1/2 is really like taking 1/2 of 1/2, which results in 1/4. Okay, the point is that generative processing involves more complex, effortful thinking about the meaning of the material. Last of all, extraneous load is effort or mental processing involved in processing irrelevant information. Let's say the teacher is teaching students how to multiply two fractions, but is disorganized and interjects irrelevant information into the lesson. The instructor has added extraneous load to the situation, making the task more difficult. Students can also contribute to their own overload. By not attending to the task or by trying to do another task at the same time, students increase extraneous load and the difficulty of the learning task at hand. To summarize briefly, our working memory has limited capacity, which means we can only think about a few pieces of information at one time. In any learning situation, there are three sources of cognitive load making demands on our thinking. Essential load is the processing we do to attend to and engage in basic learning of the material. Generative load involves deeper cognitive processing needed to understand the subject matter. It makes tasks more difficult, but the payoff is greater because students tend to develop deeper understanding of the subject. An extraneous load is the extra processing we need to do because of irrelevant information or divided attention. Overload occurs when the cognitive load in a learning situation exceeds our working memory capacity. In part 2 of this series, we will examine how teachers can manage and reduce the cognitive load associated with their lectures, assignments, and activities.